Okay, so we've established derivatives of exponential and logarithmic functions, and what we want to do now is to find derivatives of the inverse trigonometric function. So let's talk about what those are. And the first one would be the derivative of the inverse sine of x, or arcsine. You can write it in either way, arcsine of x, and its cofunction, arccosine of x. Right, so we want to talk about that one as well. Then the next things that we're going to talk about are the derivatives of the inverse tangent of x, or the arctan of x, and its cofunction, the inverse cotangent of x. Alright, for the last pair, we're going to look for the inverse secant of x, the derivative of the inverse secant of x, and the derivative of the inverse cosecant of x. So then in addition to the 4 formulas we learned above, we need to learn these 6 also. So that will give us 10 new formulas, which it's best to remember, to memorize them, but you should also know where they come from for the most part. And sometimes when you know where they come from, if you forget them, you remember how to generate them over again, or how to find the derivative formulas again. Alright, so I'm going to scroll down here, and I'll use the space below to actually go about finding these derivatives. Alright, so the process that we're going to use for all of these is essentially the same, and that is we will write the function in its inverse form, such as y is equal to the inverse sine of x. And what an inverse sine is, normally we give to the sine function an angle, and it returns to us the ratio of the opposite side to the hypotenuse of a right triangle that has that angle. And what we're going to do, so normally we give it an angle and it gives us back a sine. Well, with the inverse sine, instead of giving it an angle, we give it the sine and it gives us back the angle. So what this says then is that x, so x is a sine, x was the sine, and when we give it to the inverse sine function, it gives us back an angle that x is the sine of. So we can say that x is the sine of y, or, or that y is the angle whose sine is x. Alright, so x is the sine of y, or y is the angle whose sine is x. And so we can rewrite this equation not using inverses, and it would be x is equal to the sine of y. And of course, you know, with inverse functions, all you really do is you're swapping the x and y. If y is the sine of x, then we swap the x and the y, and we got x as the sine of y. Alright, so x is the sine of y. Then what we're going to do is take the derivative of both sides using implicit differentiation. And when we do that, we know that the derivative with respect to x of x is simply 1. And the derivative of sine of something is cosine of that thing. And since the variable is y and not x, we still need to multiply the cosine of y by the derivative of y, which is y prime. Okay, so if I were to divide both sides by cosine of y, I would get the result that y prime is equal to 1 over the cosine of y. Well, it's not optimal to leave this in terms of y. We would much rather have it in terms of x. And so the way we go about doing this is to make a right triangle that is based on the underlying assumption of this problem, and that is that y is the angle whose sine is x. So y is an angle, and the sine is the opposite over the hypotenuse. If that is x, then that would be x over 1, where the opposite side is x and the hypotenuse is 1. Then from the Pythagorean theorem, we would get that the base, the adjacent side of that triangle of y, the side adjacent to y, is square root of 1 minus x squared. And now if we're looking for the cosine of y, well, cosine is just the side adjacent to y over the hypotenuse, and so that is just square root of 1 minus x squared. And so we've returned everything from y's back to x's, and we have that the derivative of the inverse sine of x is just 1 over the square root of 1 minus x squared. And so that is the first of our derivatives there.